Hi, everyone, and thank you for tuning in to my talk today. And I also want to take a moment to thank the symposium organizers for inviting me to share some of my research that I'm working on for my graduate degree in the Poly Lab at the University of Wisconsin-Madison. I also want to start first by acknowledging that this research is only possible from the help of lots of different people and organizations as well, especially big thanks to the Apostle Island crew who made the logistics of doing research out on the islands possible for me. So environmental change has had dramatic effects on ecosystems really across the globe, and this is predicted to continue to impact ecosystems and species into the future. And areas that are relatively buffered from environmental change are likely to be really important for conservation. In general, we call these areas refugia, and the identification, protection, and management of these areas have increasingly become a focus of conservation practice to really support the persistence of species, communities, and ecosystems. I know for at least myself, refugia terminology can be pretty confusing because of the different scales and processes under consideration. Here's just a diagram with some different terminology, and some of the like terms are color coded. But Morelli and colleagues really argue for an increasingly inclusive view of refugia that really recognizes all of these different terms, and really the relationships between them are going to be important. And in fact, really underlie the idea that many different processes and scales really need to be considered when we're discussing refugia. And broadly today, I'll be discussing in situ refugia, or it's refugia that exists within the current distribution of a species or community. But I also think by the end of the talk, you'll see we'll touch on many of these different terms as well, ultimately with the hope that the identification of these areas can really help ensure some continuation into the near future. So what are we looking for in a potential refugia? In the context of climate, we're looking for areas that are resilient to climatic changes and really represent historical conditions that these species, these communities evolved in. In large part, when I'm talking about historical conditions, I'm really thinking kind of pre-European settlement in North America. And this also holds true for habitat features. We're looking for habitats that really closely resemble, again, historical conditions that really shaped how these communities have evolved. Also, at the species and population level, a refuge should have the resources necessary or demographic potential to really have a growing population that can potentially contribute migrants to the surrounding landscape. And along this idea, refugia hopefully has some level of connectivity also to the surrounding landscape, where it can be a source to areas that are maybe less optimal. And this ultimately acts to slow and resist losses due to environmental change. So why will the identification of refugia be important for the upper Midwest? And from a climate perspective, temperatures are projected to continue to warm in the region, and this will likely really have attenuating effects on winter. It is projected that snowfall accumulation will decrease, the number of snowfall events will decrease, and the duration of snow cover will all likely decrease. And winter has played really a key role in structuring these communities, and many species have really evolved strategies to take advantage of these historical winter conditions as well. So, in addition to climate change, the upper Midwest, and especially Wisconsin, has really seen substantial changes in forest composition and structure as well. We can look at this figure here, and up at the top left, we have the mid 1800s. Going down to the 1930s, we see a loss in forest cover, especially in northern Wisconsin. But interestingly, if we go then to 1990, we actually see a return of forest cover to many portions of northern Wisconsin. But while forest cover has returned to much of northern Wisconsin, it's really the composition and structure of the forest is really markedly different. We can look at the graph on the top left, and from a deciduous perspective, we can see oak hickory has decreased substantially, while aspen birch has increased. And even more dramatic, looking at coniferous species, hemlock and white pine really dominant stands on the historical landscape. But now we're only a small fraction today. And this has really ultimately resulted in forests that are compositionally less diverse and really structurally more simple than historical forests of northern Wisconsin. So why do I bring up this loss of snowpack, this change in composition and structure of forests in the region? It's because ultimately it's going to result in really a decrease in environmental complexity in the seasonal forests of Wisconsin. And historically, it was this complexity that really formed these systems and structured these communities and biotic interactions. And the species that are really likely to be hit hardest by these changes and what are in need of refugia are really what I'm calling complexity specialists. And I think a great example of this is the American marten. First, their body shape and size really lends itself well to taking advantage of complex forests with high canopy closure, coarse woody debris, snags, understory vegetation. This complexity affords them hunting opportunities and protection from larger carnivores as well. Likewise, snowpack provides greater complexity in the winter. The martens have winter adaptations to really help them take advantage of this. One, they have low foot loading that helps martens to travel on deep snowpack. And they also have behavioral adaptations, like making use of what we call the subnivium. And this is the space between the ground and top layer of snow. And you can see two pictures of that in the bottom of the slide. But this subnivium really provides a thermally stable refugium during the winter months, and it also provides space to forage for small mammals, and again, protection from larger carnivores as well. The snowpack and the subnivium that forms really adds complexity to what otherwise might appear to be a pretty homogeneous landscape, at least to us during the winter months. Martens have had a shared history among many carnivores in North America, where they've seen a reduction in their range, especially due to change and loss of habitat and forest structure following European settlement. And now we're one of the most really translocated species in North America, with each red dot here representing a translocation event. We're going to take a little bit closer look and unpack some of these translocations that occurred in the upper Midwest. So in this region, martens were in large part extirpated by the 1920s. And coincidentally enough, the first translocation actually occurred on the Apostle Islands in 1953. And they sourced martens from British Columbia and Montana, and they actually introduced what we now consider to be a non-native species of Pacific marten to the islands. During the same time, in the 50s, the Upper Peninsula of Michigan also started translocations, sourcing individuals from Ontario. And then subsequently, really through the decades, many other translocation events, they all sourced individuals from different parts of Ontario and had different relocation sites in both Upper and Lower Peninsula of Michigan as well. Back to the 70s again, 70s and 80s, Wisconsin also did more translocations, sourcing individuals from Ontario, as well as Colorado, which again, what we consider now to be a non-native Pacific marten, but they relocated individuals to the Nicolet National Forest in northern Wisconsin. And again, in the 80s and 2000s, translocating individuals from Minnesota to the Chequamegon National Forest in northern Wisconsin. And while this is not a translocation, I wanted to also highlight some work from the Poly Lab that looked at the recolonization of Isle Royale, where individuals likely crossed over during ice cover and sometime in the 90s to kind of recolonize Isle Royale as well. Despite all these translocations, though, martens are still the only state endangered mammal in Wisconsin. So we know in the mainland of Wisconsin, the recovery has been pretty slow, and that's likely due to small population sizes, low juvenile recruitment, a lack of connectivity, and that has led to really projected non-trivial extinction probabilities that question the future viability of martens in mainland Wisconsin. Also, in the Upper Peninsula of Michigan, they've also seen some slight declines in estimated abundance since the early 2000s. We also know the slow recovery is partly attributed to their diet. In northern Wisconsin, we know that their diet is mostly from really non-preferred prey items, whether it be shrews, which are pretty nutritionally limiting, or maybe competitively limiting when martens have to scavenge white-tailed deer and they're going to come in contact with other larger carnivores more frequently. This competitive limitation is also highlighted by the fact that in this isotopic space, or a way to look at kind of the overall space of an animal's diet, they completely overlap with fishers, which are really a larger, more dominant competitor in northern Wisconsin. So given that slow recovery, it was really surprising when in 2014, a visitor took a photo of a marten on the Apostle Islands. And this was after nearly 45-year absence. So when we saw this, it got us thinking, can the Apostle Islands potentially act as a refugia for martens in the state, especially given their slow recovery on the mainland? And to address this kind of larger, broader question, we had a few more targeted questions that we wanted to address. Kind of first and foremost, what is the source of martens to the islands? What does their demographic potential look like? How abundant are they out there? And then also, what does connectivity look like among the islands and also between the islands and the mainland as well? So to address this first question on what is the source of martens to the islands, we identified three potential hypotheses. One, they were a pre-extirpation holdout. So following the extirpation in the 1920s, martens have persisted on the Apostle Islands undetected and could represent a really important relic lineage of martens in the region. Next, potentially it's a translocation holdout. So following that translocation event in 1953, maybe they have gone and persisted on the islands undetected since then as well. Or third, maybe it's a natural recolonization event following these different mainland translocations through the decades as well, likely considering that they could potentially move to the islands during winter across lake ice. So to get at these questions, we used a regional genetic data set that is really pretty unique for a forest carnivore. And these longitudinal genetic data sets really make it possible to address some really interesting questions. And this is definitely only made possible by the dedication of people for over a decade now that's involved multiple state, federal, tribal agencies, even different countries. But we also went out and collected our own genetic samples from the Apostle Islands themselves and combined those with this regional data set. We ended up analyzing over about 450 individual marten genotypes from the region. So first, we kind of looked at some standard measures of genetic differentiation. And right now, I'm just showing you a multivariate plot based on the genotypes of individuals. And really, the take home here is that everybody kind of just clusters up into a big group. And this began to at least suggest to us that they're genetically pretty similar to the contemporary populations and likely were colonized from somewhere in the region and likely relatively recently because of the lack of genetic differentiation. We also wanted to look at this a little more robustly. So we used simulations where we could actually test competing hypotheses on the source and timing of the colonization. So we took our simulations and we wanted to really replicate this kind of web of translocation events and the timing of them to look at the potential sources for the Apostle Islands as well as that timing. And ultimately, really all of our lines of evidence supported recent colonization from Upper Michigan and in the last 4 generations or so. So that puts it within about the last 20 years. We can also zoom in here and look at really the unique individuals we identified on the islands. We found that at least currently they appear to be pretty abundant, and especially abundant relatively to densities reported in mainland Wisconsin. And when we start seeing, density estimates over 1 per kilometer squared, it really starts to suggest that they're occurring in pretty high quality habitat. We also looked at relatedness, so genetic relatedness between individuals on the islands. We see a few cross-island connections here, suggesting that the islands have some level of connectivity between them as well. Also, interestingly, we looked at relatedness between the Apostle Islands and a group of martens that we had samples for in northern Wisconsin, and we found one individual that was highly related between Stockton Island and the Apostle Island, and also an individual that was detected in Iron County in northern Wisconsin. So zooming back out here, we also wanted then to look more at more regional connectivity by estimating two measures of movement, really based on genetic data. So for the mainland, we estimated recent movement between two of the Michigan populations, and also found relative directional movement from Michigan to northern Wisconsin as well. But what was really surprising was when using both methods, we actually identified low levels of movement from the Apostle Islands back to the mainland of Wisconsin. So a couple of the main take homes here. We appear to have a natural, a contemporary recolonization of the Apostle Islands. Right now, at least, they appear to be pretty abundant with some high densities. And also the surprising contribution back to the mainland. So is it possible that the Apostle Islands can act as a regional refuge for martins? And that unexpected gene flow and really the abundance got us thinking and has really kind of opened up the door to future research and other questions that we're now exploring. But, it appears that the forest structure, especially the subcanopy, is much more complex than the mainland. Um, Many of the islands have Canada U, that is really functionally extirpated from the mainland. Again, in large part, really due to the absence of deer herbivory on many of the islands. And it's also likely that the structure and composition of these forests really more closely resemble historical conditions as well. There also seems to be a bit of a competitive release where fishers are absent from many of the islands that marten occur on and also appear to be at lower densities as well. Also, the preferred prey, redback voles, appear to be abundant on the islands as well. And in the short term, it appears that these conditions have really led to the demographic potential of this population to act as a source back to the mainland. And it also really opens the door for us to understand how Lake Superior might impact conditions on the islands in the future as well. So, kind of bringing it back to the beginning here, it appears that the Apostle Islands at least have the potential to act as a refugia, really hitting on many of these different processes that are going to be important to consider. And this highlights the fact that I started with, that it's really going to take a host of processes and scales to really maintain populations in the short term and bridge the gap to long-term persistence in the face of environmental change. And with that, I can take any questions.